You're welcome to today's class. In this class, we'll be going through the total surface area of a cylinder, where we'll be looking at the properties of cylinder. After that, we look at how to calculate the total surface area. We're going to be deriving the formula for calculating total surface area of a cylinder. After that, we then see how we can apply the formula we have derived. But before we go into details, let me quickly tell you that if you are new to this channel is basically for students who are having issues with mathematics and on how you can improve your maths, how you can become smarter with mathematics. I would like you to also subscribe, like, comment. If you have anything that is disturbing about mathematics, maybe a particular question or a particular topic that is disturbing, kindly write it in the comment section. Let's get started. Thank you. A cylinder is a solid that has some properties that we need to look at. Firstly, when we talk about solid shape or we talk about 3D shapes, we're talking about a shape that has container that you can put something inside it, like this. This is a solid. And let me give you this. If you look at this is like a pipe and it's a cylinder. It has curved parts and it has bottom and the top. The bottom is in form of a circle. It's a circle rather. This is a circle that's going to be used to cover this place, and we can as well use it to cover what? This place. Now we want to look at how, if the question asks you to find the surface area of a cylinder, how are you going to go about it? I always tell my students that you don't need to cram any formula. Once you know how that formula is being derived, you don't have problem with mathematics. So in this, I'm going to show you how you're going to derive the formula for calculating the surface area of this cylinder. So let's look at this. We have this. This is a cylinder. It has the bottom and the top. It's just like your tin, the tin of Milo that you put your Milo inside. It's like this. It must have a bottom, then you put the Milo inside and cover it. So that is closed cylinder. So if I want to break it down, I will cut this. Once this is cut into two separate parts, just like this. I want to cut this right now. Let's see the space, this shape we're going to get. So after cutting it, look at the shape we have. What is this shape? As you can see that this is a rectangle. So which means the curved part here is in form of what? A rectangle. And while the bottom part here is in form of what? A circle. And the top is also what? A circle. So we want to get the total surface area of this cylinder. It means we're going to find the area of the circle. The area of this circle plus the area of this rectangle. So we add everything together to give us total surface area of a cylinder. Now in that case, area of a circle here is what? Pi r squared. While this also what? Pi r squared. Right? But area of a rectangle is length times what? Breadth. But in this case, if you look at the cylinder, it has no length, it has no breadth. But if you look at where we derived it from, this is the rectangle. By the time I fold it again to form my cylinder again, so this length here is the one forming my circumference. The circumference you're seeing here, this circumference here, is not forming the circumference, meaning that the length here, the length is same thing as what? The circumference. The circumference of the base. Also, the height of this cylinder is the breadth of this. Meaning the breadth or the width is what? Is the height. Is the height of the cylinder. So therefore we can conclude circumference of the circle is what? 2 pi r or pi d. But we're not looking at diameter, we're looking at radius. So we make use of this. So we can conclude that the area of this rectangle here this is the height, is 2 pi r times what? Height. That gives us 2 pi r what? H. That's the area of the curved part of this cylinder is 2 pi r h. Everyone making sense? So we want to get the total surface area. The faces we have, there are 3 faces, this, and this. We need to add everything together. We then be equals to pi r squared in 2 places. That is 2 pi r squared plus 2 pi r h. You can see this means 2 circles, 2 area of the circle, then the area of the curved part. The 2 pi r here is the circumference multiplied by the height of what? Of the cylinder. I believe I'm making sense. So you can stop here. Once you know this, you know this total surface area of a closed cylinder. I'm still coming to that. Or you factor out what is common to this and this. 2 pi is common. So you have r left plus what? H. So you can have it. In some textbooks you see this, and in some you see this. So both are correct. Whichever one you use, you be correct. Now, this formula here is the total surface area of a closed cylinder at both ends. Of a closed cylinder at what? Both ends. But if one end is open, if you open the upper part of your tin of Milo, you misplace the cover. The upper part, the top will be open. In that case, the total surface area of that tin of Milo will not be this. It will be, since we have one circle gun, so it will be pi r squared. Pi r squared plus the curved part, which is what? 2 pi r h. So from here you know that total surface area of an open cylinder at one end is what? Pi r squared plus pi r h. If both ends are open, which is what? 2 pi r what? H. If the same thing as saying curved surface area of a cylinder. That's all. Alright, so this is the first example that we'll be looking at. So calculate the total surface area of a closed cylinder of base radius 4 centimeters and height 7 centimeters. Now before we look at it, so let me talk about this closed cylinder. In a question, if a question is specific about whether it is closed at both end or one end, but in the case of this question, it's just mentioned closed. So you assume that it is closed at both ends. Don't take it for one end. But if it is specific, that's when you apply that of what? One end being closed. So in that case, the solution to solve this, we write out the parameter. What are the parameters? Radius is 4 centimeters. But the height is 7 centimeters. The pi is 3.142. So we must make sure that anything specified for pi must be used in the question solving it. So what is the formula for calculating total surface area? Total surface area equals to 2 pi r squared plus 2 pi r h. Pi r h. So which means 2 pi r into what? R plus what? H. So let's put in the values. So we have 2 multiplied by 3.142 times radius, which is 4, into bracket radius 4 plus height, which is what? 7. So that means we multiply this together. That gives 6.284 multiplied by 4 plus 7, that is 11. We multiply it times 11. That gives 69.124 centimeters squared. Centimeters squared. Don't forget to put the unit of measurement. Don't forget that unit of measurement of area is in what? Is square units. So it now depends if it is centimeters, meters, millimeters, and so on and so forth. But it's what? Square unit. Don't forget that. So that is that on this. So we look at the next example. Okay. So this is example 2, which is quite different from the first example. So here we have a cylinder opened at one end, has a total surface area of this. don't forget we look at this opened at one end. As a total surface area of this and radius of what? 5 centimeters. What is the height of the cylinder? So this is what you're going to do. The solution. The first thing you need to do is, what is the formula for calculating total surface area of a closed cylinder or an open cylinder at one end? Don't forget, total surface area of a cylinder at one end will be pi r squared. Meaning that one circle is missing out of the two circles that it has. So it remains area of the first circle plus area of the curved pi, which is what? 2 pi r h. That's what you're going to use. And we'll be given that the formula, the total surface area of that cylinder is this. So which means our TSA here is 130.5 centimeters squared, right? That's the first part. And the radius of 5 centimeters. Radius is what? 5 centimeters. The height, which we don't know, that's what we're looking for. We want to calculate the height. So we now put in the values in this formula. So we can have, this one can be written, we can rewrite it to be pi r is common, so it remains r plus what? H. Pi r is common, it remains r here and what? 2h here. You can see 2h. You can apply this. Equals to 130. Please let me close this up now. 30.5. Right. So let's tackle the value. In here now. Good. Look at this. We're not given the values of pi. So we can use any value you want. 22.7, 3.14, 3.142. Whichever one you use will be correct. So here, let me use 3.14 for my pi. So let me put pi here equals to 3.14. So that means this will be 3.14 multiplied by radius, which is what? 5. Open bracket, radius 5 plus 2h, which I don't know. Yes. That gives me 130.5. But let me multiply this together. 3.14 times 5 gives me 15.7 into bracket 5 plus 2h equals to 130.5. So in this case, close this. So don't forget what we're looking for. It has turned to linear equation. So the first thing, let's remove this. Is either you can do it in two ways. Use this 15.7 to multiply 5 and multiply 2h. Or you divide both sides by 15.7. 15.7. So this we cancel this. You should have what left? 5 plus what? 2h equals 8.312. You can put it as 1 here. Next stage is for you to collect line frames. So because what we're looking for is h, so we need to remove this first. So that means we have 2h equals to 8.3121 minus 5. So that gives 2h equals to, when you subtract that, gives 3.3121. So next is divide both sides by 2. Divide both sides by 2. 2 cancel 2. It remains height. So that means 2 in 3, 1. Remainder 1 here. That gives us 6. Remainder 1, 5. Remainder 1, 6. And in this, that is 0. So we can have height to be 1.7. So the height of the cylinder, the height of the cylinder is 1.7 centimeters. So that is it. So in the next video, we look at a real life application of this formula that we derived. So we look at real life application. These are just examination applications. We look at real life application of the formula. Thank you very much for your time.